So hi guys, welcome to my channel. Today I'm going to explain this problem in N-ary post-order traversal. So what this question trying to say is we have to perform the post-order traversal in the N-ary tree. Like we all know that we have performed the post-order traversal in the binary tree where we are given two children like this 2, 3. So how we perform the post-order traversal in this is we are standing at 1, we go to 2, then we go to 2's left, it is nothing, 2's right, nothing, we go here, then we come back, then we go here, then we come back. After visiting 2's left and 2's right, we print 2. Post order means after visiting its left, after visiting its right, then we print post. So this is how we traverse like tree in post order traversal. Then we came back to 1, then we go to 3, we go 3 is left, nothing, 3 is right, nothing. Then while coming back to 3 we will print 3. Then 3 completed, 2 completed, 1 left is visited, 1 right is visited, then we print 1. So this is the answer of post order traversal of a binary tree. Now let's see if there is an array tree, then how we like to traversing. So let's say what we will do is the approach is pretty simple. Like whatever we are doing in binary tree, we have to follow the same approach in N-ary tree. The starting node is this. We initially visited this 3. Now after visiting all the nodes of 3, while coming back to 3, we will print this node. Same as 1. After visiting all the nodes of after visiting all these nodes means from left completed, right completed, then we print 1. I think it's clear. Let me give one more example. Then coming to 5. After visiting 5, like 5's left, which is nothing, 5's right, which is nothing. While coming back to 5, we will print 5. Now this is done. We come to right of 3. Now 6 left is done, 6 right is done. By the way, this 5 is already in our answer because we have visited left of 5, we have visited right of 5. Now 6 done, 6 left is visited, 6 right is visited. While coming back to 6, we will print 6. Now while 3 is left is visited, 3 right is visited. While coming back to 3, we will print 3. Now we will get back to 1. Now once left is visited, once this node is still left, so we will visit this. Now 2 left is nothing, 2 right is nothing, so we will come back. While coming back to 2, we will print 2. Now we will again come back to this. Now 2 nodes are already done. This is done, this is done, this is left. While this will cover, then we will be able to put 1 in our nodes, like array, whatever it is. So we will visit this. Now 4 left is nothing, 4 right is nothing, so we will, while getting back to 4, we will print 4. Now after completing 4, we will get back to 1. Now we can see that 3, 2 and 4 is completed of 1, then we print 1. So at last we will print 1. So we can see that the array is 5 6 3 2 4 1. 5 6 3 2 4 1. So let's see how we are approaching this problem. In code, how we like able to traverse it. It's pretty simple. That example by writing the post order traversal. Like in post order traversal, what we do is we write solve, we go root left, we go again solve, we go root right, then we put the current root in our answer. Now here is no left and no right, means there is one more node, so there is not a concept of left and right. But in question we are given that this part, vector nodes of children, means whatever children we have, we are given in a vector. So let's say So this is very simple. So let's say we are having let's say we are standing at 1. So 1 will be having value and 1 will be having vector of nodes of children. Means whatever nodes we can visit from 1, we are having this in a vector. So what we will do, we will simply uh, we will simply apply a for loop in this vector and visit all the nodes. So we will write a for loop and we will visit all the all the nodes, and after visiting all the nodes, when recursion come to this step, we will push it down in our answer dot push back our root val. So this is pretty simple. Let me try it on one case, and then it will be clear like how recursion is working. So first let me show you the code. So this is the code. Like I have created one vector answer. I have called the solve function and I have returned that answer. I have passed answer in this solve function. So how this recursion is working? So solve function is calling root. If root equal to null, then I'll be calling remove this. Then I'll be traversing all the nodes from which the from where we can visit. Like if we are standing in current node 1, we will apply the for loop for all the childrens of 1, like 3 2 4. Then it will come to 3, then 5 6. All the nodes will visit it, and at last we will be printing our answer. Like it's given that N-ary post order, then we are printing the answer in the last. If it will be given that in the pre-order, then we will be doing this in the this step here. So let's try it run once. We take this code. Okay. So let's see how this is working. So we are standing at 1. We are standing at node 1. So for loop goes like for I is equals to 0, I is less than children dot size. You can see here root children dot size. So root children dot size, root is 1. Now root is equals to 1. 1 children dot size is 3. So 3, then I plus plus. Then we will call the solve of root. You can see that we are calling root ka children because we have to explore this also. Means root, this one is root and this is root ka children. So let's see, root children means we are calling for 3. Okay, so this is the function. So again this will call one more recursive call. We will check that if root is null. Now our current root is this, so root is equals to 3. Now we will apply one for loop for I is equals to 0, I is less than. You can see that this is our current loop. We are standing upon 3, and what is the size of their children is 2. So I is less than 2, I plus plus. Okay, we will call. Now we will call the children solve of what is the first children, 5. We will do 5. Okay, so again the call goes like solve. Again this will go a call, like again we have called a recursion, and you can see that again this step will follows like how we have to explore. The recursion is like we are going deeper, then come explode, then this side. So this is how the recursion works. So 5, we are standing at 5, we will have to explore the childrens of 5. So let's see, for I is equals to 0, I is less than, what are the childrens of 5? No, there is no children of 5, so it is size is 0, then I plus plus. Okay, our current root is equals to 5. Here we are iterating for I is equals to 0. We have to iterate till 2. Here we are having this. So if there is no child, then if we call solve and child of 5, it will return. Why? Because of this base case. If root is equal to null, then return. So after returning it 0 0, it will, this for loop will run only once, and after completing this for loop, answer dot pushback push 5. So we will be having 5 in our answer. Now after completing this for loop, okay, after completing this for loop and printing our answer, our recursion will come to this line. After getting the like a closing bracket, it will return to this from where it has came. So now we have explored 5 iteration I is equal to 0. Now for I is equals to 1, this solve function, this will call solve 5, let me see, 5 comma 6. The second node of root 3 is 6. Then we will go like this. So again a for loop will come same like this, and the size is also the iteration will also go from I is equal to 0 to I less than 0. Why? Because 6 also do not have children. So solve will go, then it will receive null, it will return. After it will push answer dot push, and then 6 it will push. After completing this iteration, it will again get back to this, means we have completed 5 and 6, it will come back to 3. And you can see that solve for 3, let me here solve for 3, I is equal to 0 completed, I is equals to 1 completed, means this for loop is also completed. So here we can push our answer like 3. So this is how recursion is working. So I hope this is clear. Let me show you the code. So this is the code. So thank you for, I hope this is clear. Thank you for watching.